Okay, here we go. Let's see if we can take a look at some problematic queries. One of the most problematic ones I've found inside of our CRM product for our point of sale system. It is integrated into our point of sale system. We just call it CRM, right? And this particular query I found executes every time that a store personnel would pull up what we call an opportunity for the customer. So that would be it's basically just a sales lead. So this is a sales lead system. So and it might have stuff. It's going to have all the pedigree information for the customer, phone number, email address, name, address, stuff like that, and any merchandise they're in or any specific details that might be we might be interested in that the customer left us. They made a comment like I'm looking for a TV or something like that. Um, they're gonna be able to leave that information in there and store personnel can pull it up. And when they go to contact the customer, they've got all the information right there in the system. So this particular one is pretty bad. And we'll go over why. But and you'll see on the screen here, I've got some general rules you want to avoid. And these are kind of golden rules you want to avoid when programming anything in SQL Server. Because when you're thinking about SQL Server, you want to think about working in sets of data. Um, you don't want to process like individual rows. SQL Server is at its best when you can work in sets of data. So, so select star, avoid it. Top number of this, avoid it if at all possible. Select distinct. Windowing functions are better. Cursors, bad. Don't do it. Scalar functions and table valued functions and join predicates. You're going to get bad query plans. You're going to get bad memory grants using these and join predicates or even selecting from them. In any case, you're going to get bad stuff happen. Sometimes you got to use them, right? I get it. Everybody gets in a big hurry and we just want to get across the finish line on stuff. But as a general rule, especially in join predicates, you want to avoid them. Order by. Uh, SQL servers are generally the most expensive boxes in your enterprise. That means those compute cycles are the most expensive compute cycles in your enterprise. And you want to avoid, as much as possible, you want to dedicate that CPU load to processing data, to getting data out of your SQL server and writing data to your SQL server. You probably don't want to spend those expensive compute cycles sorting data. It's much better to let your client side do that. So let's without that, and then here's some free stuff that anyone can go download it to analyze query plans. Brent Ozar is a great toolkit for analyzing your stuff on your SQL server. Who is active? This is all free stuff, and this is basically any DBA is probably bread and butter. There's these three things right here. You're not doing much without these three things. And so without further ado, let's get into the query. So this is it. As you can see, this is doing a window function to get a row ID, maybe for some sorting later. We'll see. And again, as I said, all the pedigree data for the customer, merchandise they might be interested in, if they've deposited any money in the opportunity, that means they're serious about it, whatever. And we get down here and we see, well, we got a bunch of one inner join, tons of left outer joins, and the problem should be pretty obvious by now. Um, Yikes! Top one of the don't do that. Um, Select top n number here, phone number from this table, or deleted doesn't equal one, and ordered by is primary. Now that's curious. And that it is particularly curious, this one. This is a bit flag. Well, why would you want to order by a bit flag? So it's a little incomprehensible to me. The value is either going to be 1 or 0. And I get that they're trying to just get the top one number, but what if this isn't correct? But that's neither here nor there. Um, so basically, the point is they just want to get the top number where it's primary, where it's marked primary equals 1, right? So descending would be in descending order. So 1 to 0. Bits can only be 1 or 0. So in descending order, it would be 1, then 0. So essentially, it just wants to get the top one number that's marked primary equals 1. So why wouldn't they write it like that? Yikes. So this is probably going to create some problems. Oh, spoiler. Okay, let's go ahead and run that query real quick. And we press Control M to turn on viewing the execution plan. And we'll take a look at it in SSMS. And we see we're going to read it from right to left because that's how you analyze every query plan. And things are looking okay here. Nice thin lines across the board. We got lots of index. Whoa. So we got our problem right here. We've got two big fat lines right here coming through. And if we hover over this operator, we can look to see what happened here in this operator. So it looks like we read through over 2.5 million rows of data just for this operator. Now, granted, we read through it in a third of a second, but then we had to go back over here and sort that data and over another half a second. So here we're a little over a second to get the data out of here to read all those rows and then come here and sort it. That sounds pretty quick, right? What's the big deal? Same down here, we have the same thing where we read through 713,000 rows of data. And in just under half a second. So what's the problem? We got a second there for that operator and half a second basically in total. Here's the problem. And we're going to use one of those tools I said. We're going to pull up in SQL Century Plan Explorer. And we're going to look at something. Wait for this to load up. Remember I said the size of those lines are pretty fat. And here we see the same row counts we saw earlier. Over 2.5 million rows here, 713,000 rows here. Okay, fine. Now SQL Century Plan Explorer lets you do the line width, my data size. Bam. We see 90 megabytes of data and 105 megabytes worth of data. Yikes. Every time this runs, which is opening an opportunity inside of the point of sale system, which if we put our thinking cap on here for a second, is something that's likely to happen a lot. With 350 stores, 5 workstations at those stores, you could have potentially 5 workstations. I can do the math, but over 1,500 computers hammering this query at one time. So 90 megabytes and 100. So basically, we'll call 195 megabytes every time this query runs and has to sort through all that data. That is not a good state of affairs. You're going to have lots of problems. And we can see one of the problems here. If we go back to SSMS, we see we've got a yellow bang over the select operator. this is a warning. The query grant detected an excessive grant. So right now we were already granted too much memory. The SQL Server, the engine saying we were granted too much memory for this query. We only used 16 kilobytes. We were granted 1024. Now that is the default allocation size, but it's saying, I only had to use 16 kilobytes of memory for this query. So, and I believe it's these two operators here causing the problem, the inaccurate grant, and just the simple fact of this is using too much, pulling back way too much data, uh, just to result in one row coming back, right? So problems here. These two joins are the problem right here. Why? The top one selected performs that's an implicit sort already. You're sorting these two columns, and then it's another double whammy with these. But that order by is primary. What can we do about this? How can we change this query? Now, I can't change this query. I have to go present my findings to the vendor. But if I were writing the query, I were writing this product, how would I change these two queries in order to get across the finish line? And the finish line being, I want to pull back only the row I need. I want the amount of data being sifted through in this query to match uh, what's being returned, right? Okay, so you'll see also at the top of the query, I set statistics IO on here. This is another good troubleshooting thing. If you're not sure about what your query is doing behind the scenes, how much work it's doing, you can turn this on. You can copy this output. Okay. And I host this internally in our system, but there you can do statisticsparser.com and paste your output in there and parse it, and it will show you. Here's the amount of work I did per table. Here's the logical reads. This is the number of pages it had to sift through to get the data. And right now, in total, in sum, we're looking at 26,964 pages just to return one row. Hardly worth it. Hardly seems worth it. Hardly seems worth that much effort. Okay, so let's look at what we can do. These two joins to make things better. So I rewrote some of this, and we can look. And I did this to make it easier to read. Okay, so initially what I did is I got rid of the top number, right? You no longer see that in the join predicates here. And these select statements, gone. Well, I also put this inside of another select statement. So this is technically a select access from select. So I alias this select statement into another one. And I'm selecting from it, and I'm taking advantage of this row operator, this row ID window function, which is there, and they are not using it here at all. So why even have it if you're not going to take advantage of it? So I'm taking advantage of this. So I get the same result, but I get it without the nonsense, right? And you'll see what I'm talking about here. So we'll Control M, turn on execution plans. Did I turn on statistics? Okay, good. So here's our new execution plan with those changes. And we see the yellow bang is gone. And if we look at our two operators here, Those are much smaller lines. Now let's take a look inside Century Plan Explorer and see just how well we did. Okay. Wow. We knocked both of these operators down to one row. One row. From, if you recall, 2.5 million and 713,000, almost 3 million rows worth of data to return one row. And just with that simple change of not doing the top end and order by, we get right to the row we need. That is a result, my friends. And here, that warning about the excessive memory grant is gone. And now we see the processing load for this entire thing is generally the same. It is evenly balanced. Now, we could go even further with this, with getting rid of this, but I don't necessarily have a problem with the max here as long as it's not in a where clause or the join predicate, right? Okay. So we can also look at the statistics.io output. Let's look at that real quick and see how good we did there. Okay, so let's go ahead and paste this in, parse that. Whoa. We read 3 pages there and 4 pages there. In total, we read 32 pages. Just as a reminder, we were at over almost 27,000 pages. And we knocked it down to 32. Why is this important? Well, in the architecture of our CRM, this is accessed over the internet. So this is not a LAN product, in other words. So when you're, even if it was a LAN product, this is still problematic. So when you're accessing stuff over the internet, your internet connection, imagine you're having to wait every time you want to pull up a customer. You got to wait on, almost 200 megabytes worth of data every time you do it. But even with today's internet speeds, that's egregious. I think it's much easier and be much quicker to pull up 21 bytes of data, 139 bytes of data, less than 200 bytes. That's bytes, not megabytes, bytes. So much quicker, much snappier response time when you consider how this product is employed at a store. All of this information has to go across the internet, but even if it was at LAN speeds, that's still egregious. That still takes way too long. And it hammers your SQL server when you have to go sift through 200 megabytes worth of data when this thing runs so often. This thing is running very often. So getting across the finish line here on this is just write. What's the takeaway here? Write better queries. Write better queries. Don't do this stuff in a join. This is not good. And I understand developers are sometimes pressed for time and you just got to get something out the door. But this should never be happening. This is a much cleaner way to do it. And you get the row ID you need. You still employ the same, you're still only getting the one row you need. Don't do this. That's the takeaway here. Write, bitter, join predicates. Stop doing nasty stuff in your where clauses. You will get better queries as a result.